Hello everyone, I welcome you all, and in this video we are going to discuss the numerical from your unit number 1, that is vector analysis, and this numerical is basically related with the coordinate system transformation. So here in this case, if you see, we are given with some vectors which are in the rectangular or Cartesian coordinate system, and we have to convert that your rectangular coordinate system into the spherical coordinate systems. So before we begin, if you have any queries regarding online batches, so you can drop me a mail onto this my email ID. Okay, fine. So we will begin with this coordinate system transformation table where we are going to convert that rectangulars into spherical coordinate systems. So we will see the transformation table that will be acting as a base for your this numerical. So we will start with that one. Okay, so converger table that we will be using throughout this numerical will be like this one. So since we are given with this given vectors in terms of that rectangular or Cartesian systems, so we have that components to be ax cap, ay cap, and az cap. And next we are going to convert it into what? Spherical coordinate system. So for the spherical coordinate system, what we have the coordinates we have that to be the r, theta, and phi. So here the components will be what? We have that to be the air cap, a theta cap, and a phi cap. So these are the your respective components of your spherical coordinate system, that is AR, A theta, and A phi. Now we will look out what is the very first element. If you have the dot product in between that AX and AR. So very first element will be what now? It will be sine theta cos of phi. Okay, fine. Uh, it might be hard to you recall this table, so well, I hope that you know the convergent table for your Cartesian to spherical system. So for your reference purpose, I am going to make use of that one very firstly. So what is that table we have for Cartesian to spherical system? That is your cos phi. Write it over here, cos phi, sin phi. Okay, fine. Now you just put the very first element, that is sin theta over here. Sin theta, again sin theta over here, done. So this is how you are going to make use of the your previous table in order to convert that Cartesian to spherical one. So very first element will be what now? The dot product in between the ax and ar will be sin theta cos phi. Dot product in between ay and ar will be what now? Sin theta sin phi. Now the dot product in between that az and ar. So it is equals to cos of theta. Now your second column. So second column, you just keep this cos phi sin phi as it is. Again, this is for your simplification purpose. It is quite harder to remind this table, so we will try to make it easy. So keep this cos phi sin phi from your this column as it is. Now assign cos theta over here. Right, cos theta over here. So that will be what now? The dot product in between that ax and a theta will be what? Cos of theta cos of phi. Now you just again write this cos theta over there. So this will be cos theta over here. So dot product in between that ay and a theta is equals to what? Cos theta sin phi, and dot product in between that az and that a theta. So that will be equals to minus of sin theta. So this is what we have. Now the last column over there. So dot product in between that ax and a phi is equals to what? So that is minus of sin phi. And dot product in between that ay and a phi is equals to what? That is equals to cos of phi. And dot product in between that az and a phi, so that is equals to 0. So this is your convergent table. See, this table is quite hard to remind, but with the practice it will be easier for you. So you can make use of the previous table, that is coordinate system transformation from Cartesian to cylindrical one. You just put that cos phi sin phi over here. Again cos pi sin pi over here, assign sin theta, cos theta over here, and here in this case you just write cos theta minus sin phi cos phi. So based on your practice or your method of reminding that one, you just have to write this table somewhere so that we can make use of it in order to simplify this numerical. See, this is not necessary that you should write this table in your theory examination. You just have to mug up it up, and with the practice you will come to know what is the dot product in between these components, so that we will write the answers over there. Okay, fine. So this table we will be using throughout our numerical. So take the screenshot, and now we will begin with what is given to us and what is asked to us. So within this very first part of the numerical, we are given with any vector phi x cap at point A equals to 425 and 120 degrees. Now, if you look out, so what is this given vector A? So we are going to assume, or we are going to rename that your very first vector given to be is vector A, and it is equals to what? It is equals to phi x cap. Okay, fine. Now this vector is in what? This vector is in the rectangular coordinate system, and it is located at point A. But if you look out for the coordinates of point A, so it is expressed in terms of cylindrical systems, that is r, theta and phi. Since we have the two angles over here, 25 degree and 120 degree, and this is the numerical value that shows you what? That shows you the radius of that spherical coordinate system. Okay, fine. Now, what we have to convert? We have to convert this vector A, which is basically in the rectangular coordinate system, into what? Into a spherical coordinate system. So, then in this case, how you are going to represent that vector A in terms of that spherical coordinate system? So, it will have the components along AR, AR cap. So, this capital AR is what? Magnitude along the R direction. This capital A theta is what? Magnitude along a theta direction, and this a theta cap, it shows you components along the theta direction, and this is what we have, the a phi cap in the phi direction, magnitude along phi direction. Okay, fine. So we are going to write it as capital of a phi into a phi cap. Okay, fine. So assign some equation number to this one. So this capital AR, A theta and A phi, that shows you the magnitude along R, theta and phi direction, and this AR cap, A theta cap and A phi cap, that shows you the components along that R, theta and phi direction of the spherical coordinate systems. Now we will start with this conversion. So what we have? Very first element is we have that to be the AR. So what that AR it should be? This capital AR is magnitude along R direction, and that is equals to what? Your given vector A, which will have the dot product with respect to AR cap, or you can say the projection. So this AR is nothing but what? Projection of your vector A in the R direction. Okay, so we will write that vector A as it is. So what we have, that vector A to be phi x cap, sorry. So your vector is what? That is phi x cap, which will have the dot product with AR cap. Okay. Now what is the dot product in between that AX and AR? So from this table we have the dot product in between that AX and AR is equals to what? Sin theta cos phi. So that's why we will have that AR is equals to what? This phi will be as it is, and dot product in between that AX and AR is equals to what? Sin theta cos of phi. Okay, fine. So this is what AR we have. Now since we have the value of that theta and phi, or this phi x cap is located at this location, that is 425 degrees and 120 degrees, which is expressed in terms of the spherical systems. So we are going to put the values of that one. So this phi into sine of theta. So what value of that theta we have? So we have that theta to be equals to 25 degrees. Now what about cos phi? So we are going to put the value of that cos phi, and that phi is equals to what? 120. Now if you simplify this one, so you will find that AR or projection of vector A in the R direction, which will have the value equals to minus of 1.0565. So this is what? This is your AR in the R direction. Assign it some equation and okay, so this is your very first element out of your equation number 1. Now next element is what we have? We have to find A theta. So what? How you are going to write that A theta in the similar fashion? So your vector A, sorry, not vector, your capital A theta, that is magnitude along the theta direction, will be what now? Your given vector A, which will have the dot product with respect to theta. Okay, fine. Now in similar fashion, very firstly, what is your vector A? Vector A is given to be 5ax cap, which will have the dot product with respect to A theta cap. And what is that dot product in between that ax and A theta? So we are going to make use of this table. So we have to find what? We have to find the dot product in between that ax and theta. So dot product in between that ax and theta is equals to what? Cos theta cos of phi. So the dot product in between that ax and A theta is nothing but cos of theta from that convergent table, cos of theta into cos of phi. Okay, now you just have to put the values of that theta and phi. So that your given vector is located at the values of that r theta and phi, and that value have been given where we have the theta is equals to what? We have theta is equals to, you can see over here, yeah. So this theta is equals to 25 degrees. Now we have the value of that phi. So here in this case, cos of phi is equals to what? Put the value of that phi, that is equals to 120. So from that you will find that A theta is equals to minus of 2.2657. So this is the value for your A theta. Assign some equation number to this one. So this is the second element that we will be needing. Now we have AR, A theta. Now we will move on to A phi. So what will be that A phi? A phi is nothing but magnitude along the phi direction, which is nothing but the projection of vector A in the A phi direction. So this is your A phi. Now the dot, we have to find out what? Your vector A is given to be what? 5x cap, which will have the dot product with respect to A phi cap. Now from that convergent table, what is the dot product in between that AX and A phi? So the dot product in between that AX and A phi is equals to sine minus of sine phi. So dot product in between this AX and A phi is equals to minus of sine phi. Now you just put the value of that dot product in between AX and A phi, and we have that value to be minus of sine phi. So this term will be equals to what now? Minus of phi sine of phi, and from the given we have the value of phi, and what is that value of phi? That is equals to 120. So put that phi is equals to 120, and if you do the calculations you will find that your A phi is nothing but minus of 4.3301. So assign some equation number to this one. So this is your third element that we will be needing to find out what is that given vector A in terms of r theta and phi. Now we are going to combine all of the four equations that we have written. Okay, so combining equation 1, 2, 3 and 4 we get. So I am going to rewrite it again for you so that you will not get confused, or if you have the screenshots or if you are going to take the notes over here, so you will see that we have expressed that vector A in terms of spherical coordinate system as this, that is AR, A theta and A phi to be this one. Now we are going to put that values. So what value we have for that AR? We have that AR to be minus of this 1.0565. So put that value over there. So AR is what? Minus of 1.0565 AR cap. Now what is A theta value? So here we have that A theta to be what? Minus of 2.2567 A theta cap. And what about this A phi? So we have that A phi to be minus of 4.3301 A phi cap. So this is your vector A in terms of the spherical system. So with this we are done with the very first part of the numerical. We have expressed your given vector A in terms of the spherical coordinate system. Okay, so this is your final answer. Now we will move on to the second part of the numerical. In the second part of this numerical, we are given with some vector. So we are going to give some name. We are going to assign some name to that vector, and let us assume that your that given vector is vector B, and it is equals to this. That is your 4ax cap minus ay cap minus 4az cap, which is located at point B. Okay, sorry, it is given to be at point B, so we will assign some another name to this vector. So it is located at B, which is with the coordinates -2, -3, and -4. So let us say this is your coordinate, sorry, this is your vector P or your vector Q. Okay, so this is your vector Q, which is given to be 4ax cap minus ay cap minus 4az cap, which is located at point B -2, -3, and -4. Now, what we have to do, we have to convert this vector, which is located at this point, into spherical systems. Now, if you look out for this vector, so you will find that it is in the rectangular system, as well as if you look out at that point B, so it is also given in terms of that rectangular or Cartesian systems. So, very firstly, what we have to do, we have to convert that your point B, which is basically in a Cartesian system, -2, -3, and -4. So we have to convert this point B into spherical coordinate system, into spherical system. Okay, fine. Now what we have for that conversion? So we have this, your vector R in spherical system is equals to what? It is square of the rectangular system components, that is square root of x square plus y square plus z square. Now we have the value for that x, y, and z. So what is x we have? That x is equals to -2 square. We have that y is equals to what? -3 square. And we have that z value to be equals to what? 4 square. That too taken in the square root. So that this calculation, it will give you the value of that r. So this r is equals to what now? So this r, it will come around 5.3851. 3851. So this is your point R. Okay, sorry. This is your R of the spherical system. Now next element within that spherical system, we have that to be the theta. And what it should be? So theta, if we have the Cartesian coordinates, and if you want to find that theta, so that theta is equals to what? So theta we have cos inverse of z by r. So this gives you value of theta. Now what we have the z just now we have found, and r, sorry, we have found r value over here, and z is given to us. So cos inverse of z. So z is what? 4 divided by r. So from this we can get the value of that r. So that r is equals to what now? 5.3851. This is your theta value. So theta is equals to cos inverse of your that division. It will come around 42.03 degrees. Okay. So we have that theta is equals to 42.03. So this is the second element that we will be using throughout the numerical. So we have that r, we have theta. Now we are going to find out what is the value of that phi. So phi in spherical system is equals to what? Tan inverse of y by x. So this phi is equals to what? Tan inverse of y by x, which is equals to what now? Tan inverse of y upon x. So we have that y is equals to what? Minus 2, sorry, minus 3, and this x is equals to what? Minus 2. Okay, now here comes the tricky part. Now if you look out, this x and y, they have the minus values. So that means what? The quadrant is being changed. So in order to match up with that, we have to add it with respect to 180 degrees so that you will get the correct answer. So this is the most tricky part within this numerical. If you come to know about it, it is easier for you. So if any of the component of this tan inverse of this y by x, if any of the component is minus, so you just have to add up with respect to that 180 degrees. So this is the answer that you are going to find. Okay, so well, I hope you just take the note down over there. Okay, so this phi value, if you are going to calculate that one, so it comes around 236.30 degrees. So this is your phi of the angle. So we have that phi is equals to 236.30. Okay, now we have the values of that r, theta, and phi. So hence, what we have done? Sorry, we have converted given point, which was basically in the rectangular system, having the coordinates of minus 2, minus 3, and minus 4 into what? Into cylindrical system. Now we have expressed that point B in terms of cylindrical systems having the coordinates like this. So this is your R, 5.3851. So this is your theta, that is 42.03, and then we have the phi, which is basically what? 236.30. Many students failed over here because they don't know why to add this 180 degrees over there. They just simply go with this tan inverse of minus 3 by 2. They will find one angle and their whole numerical it will get wrong if they don't have the correct value of that phi over here. Okay, fine. Now we will move on to this conversion of your given vector into its spherical components. Now we have assumed that vector q to be this 4x cap minus 4x cap minus ay cap minus 4az cap. Now this vector q in terms of spherical system will be what now? In terms of spherical system, so we have to express that vector q in terms of r, theta and phi. So this vector q will be what now? Qr, ar cap, this this is your q, theta q theta, a theta cap, and this will be your what? Q phi, a phi cap. So this is what we are going to express your given vector q in terms of r, theta and phi. Okay, so assign some equation number to this one. Now we will begin with finding the value of that QR. So what is QR? So QR is nothing but your magnitude along R direction, which is basically what? Projection of your given vector Q into AR direction. And we have that vector Q which is given to us is what? That is 4AX cap minus AY cap minus 4AZ cap, having the dot product with AR cap. Okay, fine. Now what is the dot product in between that AX and AR? So you can use this reference table over here. So dot product in between that AX and AR. So dot product in between that AX and AR is equals to what? Sin theta cos phi. So dot product in between that AX and AR is equals to what? Sin theta cos phi. Now this minus AY. So this minus AY. So AY dot AR. AY dot AR is equals to what? Sin theta, sin phi. So put that value over there. AY dot AR is what? Sin theta, sin phi. And what is the dot product in between that AZ and AR? So dot product in between this AZ and AR is equals to what? Cos of theta. Okay, fine. Now we have the values of that R, theta and phi from your previous slide. So put the value of theta. So we have that theta to be what? 4 sine of theta value. We have that is to be equals to 52, sorry, that is not 52, that is 42, 42.03. Cos phi is equals to what? We have found that cos phi is equals to 2 236.30 degrees. Then again put the values of that theta over here, sine of 42.03, sine phi. So we have that phi is equals to what? 236.30 minus 4 cos of theta. And what is that theta value we have? That is to be 42.03. Now simplify that, and after simplification you will find that QR is equals to this much. Sorry, that is not theta, that is QR. I might have got confused over there. So this is what we have, that QR, and that QR is equals to what? You will find that to be 1.2904. So this is the very first element that we need to find in order to get the value of that QR. Assign some equation number to that one. Here in this case, I'm going to say it to be 2. So this is your QR. Now we are going to find out Q theta. Okay. So Q theta is equals to what now? Q theta is nothing but projection of your vector Q into a theta direction, and we have the given vector Q to be what? That is for ax cap minus ay cap minus 4 az cap, having the dot product with a theta. Okay, fine. Now you can refer that table. So what is dot product in between that ax and a theta? So dot product in between this ax and a theta is equals to cos theta cos phi. So that is cos theta cos phi. Now dot product in between that ay and a theta. Dot product in between this ay and a theta is equals to what? Cos theta sin phi. So we have that to be cos theta sin phi, and dot product in between that az and a theta. So az and this a theta. So we have that to be minus of sin theta. So that will be what now? Minus 4 into minus of sin theta. So that will be plus of sin theta over here. Okay. Now we have the values of that theta and phi. We are going to put that values within the equation and simplify that one. We have theta to be 42.03. We have the cos equals to 236.30. We have minus of theta, that is again 42.03. We have sine of phi in between that one, that is 236.30. And we have again 4 sine of theta. So we have that sine theta to be what? 42.03. Now if you simplify that one, you will find that value of the q theta is equals to 1.6745. So we have the second element for your that spherical system. Assign some equation number to this one. So I guess this is equation number 3. You can refer previous slides. Now we will find out what is your QR value. Okay. So what will be the QR? Not that will not be QR. What we need to find r theta and phi. So we have to find out what is q phi. So q phi will be what now? Your given vector q is projection onto the a phi direction. Now rewrite that vector q, and that vector q is equals to what now? For x cap minus ay cap minus 4 az cap, having the dot product with what? A phi cap. Okay, fine. Now, what is the dot product in between that ax and a phi? So, dot product in between that ax and a phi is equals to what now? We have that to be minus of sin phi. Minus of sin phi. Dot product in between that ay and a phi. So, dot product in between that ay and a phi is equals to what? Plus of cos phi. And dot product in between that az and a phi. So, dot product in between az and a phi is equals to what? We have that value to be 0. So, what is left? So we are with this minus 4 sine of phi minus cos of phi and you just simply put the values of phi over there. So we have that phi from the previous slide, which is equals to what? 236.30 minus cos of 236.30 degrees. Now if you simplify that one, you will find the value of that q phi, and that q phi is around 3.8826. Okay, fine. Now we have the value of that q phi. Now assign some equation number to that one. So we are going to say it to be equation number 4. Now we have the values of that r theta, qr, q theta and q phi. Now we are going to combine all of that 4 values, and we are going to rewrite that vector q, which is expressed in terms of that spherical coordinate system. So we are going to combine equation 1, 2, 3 and 4, and we are going to rewrite that equation. It will leads to what? We have the vector q. This vector q is equals to what? Qr ar cap. We have that to be what? Q, q theta a theta cap, and we have that q phi. So that q phi is equals to what? Q phi a phi. Okay, fine. Now put the values of qr, q theta and q phi. So you will find that one qr, we have that to be 1.2904 ar cap. We have q theta, which is equals to what? 1.6475 a theta cap, and we have that q phi, which is equals to what? 3.8826 a phi cap. So this is your vector q, or given vector from your part 2, which is expressed in terms of the spherical system. We have converted that rectangular system into the spherical system. So this is your final answer. Okay, so with this we have ended our numerical, though it might be lengthy, but it is quite a tricky one. So be careful with that your simplification. And if you appreciate my efforts, so you can hit the like button and share it among with your friends. So thank you.